Welcome to the ACS Technical Center. I'm Troy Bedell. Today we're going to be talking about the AccuMeter Blender. To start with, we're just going to give you a quick overview of the components. So on this blender we have touchscreen control. We start at the top. We have the vacuum receivers, which aren't included with the blender, but below those we have reload hoppers. Inside the hopper there's a plunger that loads the material into this next hopper, which is your weigh hopper. This one sits directly on a load cell and measures the weight in the hopper. Below that we have variable speed motors and augers to feed the material. Compressed air needs to hook up at the top, and then if we walk around here we can take a quick look at the controls. So bottom box is your PLC power supplies. So we have two 24-volt power supplies, one's for the input and output, the other one's for the power for the screen and the PLC. Then we have a 12-volt power supply that supplies the excitation voltage to the load cells. And in this particular panel we have a MyView router that allows data acquisition. Above this panel you'll see our drive panel for the motors. All our motors use AC frequency drives, so they're all variable speed. We use some different renditions of drives. This one happens to be the ABB. At the top there's a contactor for your safety, and then some fuses and breakers, and that's your main control components. Next we're going to talk about setting up your control and operating your blender. So from your main screen you'll see you have start stop, and then you have each individual hopper. It depends on how many components you have, usually 4 or 6, any combination. And then below here you'll see your mass flow hopper. This blender works a bit differently than a batch blender. Instead of weighing all the components in a batch, the AccuMeter Blender weighs each component individually and runs continuously. So most of the time these blenders are used for extrusion for a continuous process. To change recipes, you just touch the hopper. It'll show you your percentage. So if we change this percentage, you'll see that it gives us a message that pops up that says does not equal 100%. It forces you to make the recipe 100%. So we'll change this to 45 to make it 100%, and then you get a check mark to accept the recipe. So we'll just click check there. You can also see on the screen that it's going to give you extruder pounds per hour, and it gives you your max and min blend rates and your current rate. Also from this screen you can access the recipe book, so we can save up to 50 recipes on this. And it also gives you inventory information for each hopper and the total blender. To to reset the totals, we just hit this button, and then you'd hit yes if you want to clear the inventory. From this screen you also have manual mode. Manual mode lets you run each feeder individually and open and close your reload valves that are located inside the hoppers. You can also set a speed for each feeder. So the next thing we'll go through is your your settings menu. So we'll touch the ACS logo and it brings up your initial settings. So hopper setup just gives you your hopper size for each hopper and for the mass flow. It also shows you some information about the mass flow, upper limit, lower limit, and mass flow minimum hopper weight. We're going to skip calibration for a second. The next thing is display setup. This gives you your IP address of your display. This has a built-in VNC server, so you can remotely access the display if you hook Ethernet to it. It also gives you your serial number setting and your time and date. Below display settings is units. We can do English or metric. If you change from English to metric, you need to recalibrate in metric. And then first in, first out diagnostics. This screen, while we're running, and we're going to show you this blender running, it samples the weight per RPM value of the material, and it updates it into a first in, first out table. And this will show you what the values are and whether you're steady. We'll explain that a little bit further later. Next we're gonna go, we'll do calibration. So to calibrate, you touch calibration, scale calibration, and it's gonna show you your cal weight value, your zero, and your tare. So what we'll do is to calibrate this unit, where did the weight go? I just saw it. There it is. We'll get our known calibration weight stamped on this weight. It gives you the what it weighs. So we'll make sure that matches here. It does. So the first thing we'll do, we're going to do the mass flow since it's easier to reach. So we'll hit set for the 0 because we know it's empty. And then we'll hang your weight from the hopper. And once you get it hung up there, you'll just take a look, make sure your bit value isn't moving right here. Once it's done moving, hit set, and the mass flow is calibrated. So you can repeat that process for the other 3 hoppers. The other thing under calibration is feeder calibration. Feeder calibration gives us an initial weight per RPM value. So when you initially take this out, set it up, we don't know what kind of material you're running through it, and every AccuMeter Blender has a custom setup, so the hoppers will be different from one order to the next. So the best idea is once you get it filled up with material, you want to go ahead and do a feeder calibration. So we'll just do a feeder calibration on feeder number 3 so you can see what happens when we do it. So we'll touch 3, hit enter. It gives you how much weight we're going to dispense from hopper 3, the speed of the motor, and the current weight. So we're going to press here to begin. You'll see the hopper reload. Once it hits the reload, you'll see the auger start to spin, and you'll see the weight value change. So after it fills the flights, you see the weight value climbing. And what's going to happen once this calibration is complete, you'll see this calibration value update. And you can see the number keeps going up here for your current weight. You should only need to do this feeder calibration on initial startup, or if you change material that has a big variation in bulk density. So once it hits our target, you'll see it says calibration completed successfully, and you'll also see that calibration value updated. So next we'll look at alarm settings. So we have a couple different settings, and you can see they're for hopper 1, 2, 3, and then your mass flow is over here. So we have no flow, which means we're not seeing any weight loss coming out of the feeder. You can have that set to yes for alarm or no. We also have reload too long, which means we're not getting material into your weigh hopper from the hopper above it. So it could be that your loading system's off or there's no material available to your loading system. No material is when we're completely empty. Load cell failure is when we're not seeing the proper readings from the load cell. And load cell over max is if for some reason the load cell is overloaded. So if maybe somebody put their hand on it or set something on the weigh hopper. And also we have a blender cannot keep up, and we have stop blender on bad blend. So if we can't make the proper blend, it'll make the blender stop. The difference with a continuous blender and a batching blender, the augers are limited by the size of the auger for how much rate they can run. So you can't run every recipe from 0 to 1,000 pounds an hour necessarily with each auger. You have to have the augers sized properly to the material you're running. And we basically have the same alarm values for the mass flow hopper. Alarm log will just show you the logged alarms we've had. And then the next thing we'll do is go to advanced settings, touch here. And we have some advanced setup features, advanced hopper setup. So we spoke briefly about the first in, first out filter earlier, or table. And here, this is kind of where we set up how that table works. So we have a feed factor filter. That's the number of samples we take to put into the first in, first out table. We have a steady feed window. That's the variation around the median that the samples can be and still be acceptable. Max weight throughput per RPM. So you can set a value in there to limit the weight throughput per RPM value. Your reload percentage, that's when this hopper refills with material. And then your learn percentage is the size of the sample we take to put into the first in, first out table. So every 10% of the hopper, basically, we're taking a snapshot of the weight loss and put it into the first in, first out table. And that's how we calculate how fast to run the augers and maintain the proper recipe. From this screen, you can also select your number of hoppers. So like I said, you can have up to six hoppers. And it just depends on what you have. Like if you want to add a hopper and you added a fourth station, you can change it here on the screen. And then at the bottom, we have the mass flow settings for the first in, first out. Next button down here is motor speed limits. So we have a max speed of 100 set. We don't use closed loop feedback since we're using AC drives and they're 100% linear. We don't need to look at speed feedback. We just know that when we send 5 volts out to the motor, it's going to go half speed. When we send 10 volts out, it's going to be full speed. And then we limit the speed between 5 and 98% so we don't trip the motor out on overcurrent from running too slow or too fast. Advanced alarm options. So we discussed the no flow alarm earlier. You can configure this alarm. So if you're running a very small additive and it's not losing weight very quickly, you can set a timer for your no flow. Normally it's set to 30 seconds and we want to see 10 bits move. If you don't see 10 bits move in 30 seconds, you can increase this timer to 60 seconds for 10 bits, or you can lower the number of bits we want to see. So that way you're not going to get an erroneous alarm all the time. Max load cell bits allowed, so that's 24,980. That's basically your resolution too. So each of these hoppers is divided up by 24,980 parts. System unstable alarm. We can set an alarm in here, and if the system isn't running steady after a certain amount of time, it will give you an alarm. Hopper empty percentage. That's when you get the no material alarm. That's how low the hopper has to be to get it. And then unable to achieve rate during startup, we give it 300 seconds to dial the blender in before we start giving the alarm if we can't keep up or we can't go slow enough. And then we're not going to go over advanced feeder linking. That's a special feature. If that's something you purchase, and then you can consult the factory about that. Also security, we can set up passwords in here. So you see you have an operator, a setup, or an advanced settings password. And you can turn the security on and off in simulation mode. So you can turn simulation mode on if you're doing some training and you wanted to walk through it. So basically that's all your settings. What we're going to do now is we're going to go ahead and run the blender and show you what it should look like under normal operating conditions.